Hi, let's talk about the Kubernetes cluster components and how the workflow is in a Kubernetes cluster. So this diagram I have taken from the official Kubernetes documentation. If you look at this diagram, we have this control plane and we have these nodes. Firstly, there is a cloud provider API. So this is nothing but the Amazon like AWS and GCP, etc. So you can consider this, imagine this for now to be a user, which is typing commands through kubectl. So in a cluster, we have this control plane and these nodes. So think of a cluster as a company. So in a company, there is a board basically, and then there are employees. So the decision is made by the board, and it is implemented by these employees. Similarly, in this cluster, we have this control plane. It is like the brain of the cluster, and all the decisions or all the actions are decided here. And then these actions are carried out by these worker nodes. So talking about these components, let us start with the Kube API server. So Kube API server is basically responsible for all the communication that happens in the cluster. So for example, whenever we would type kubectl get pods, then the get HTTP request from the kubectl will be sent to this Kube API server, and then it can interact with the HCD, it can interact with scheduler and the kubelet, etc. So this basically is facilitating the communication inside a cluster. Then there is HCD. So HCD basically is a highly available key value store. So this is basically responsible for storing all the data present in a cluster. So all the resources, all the configurations and metadata, etc. All that is stored in HCD. And then there is this scheduler. So whenever we would want to add a pod, so the scheduler will decide which node should we be adding the pod to. So it will look into like which node will have which node has lesser workload, which node has constraint, etc. So all those things are decided upon, and then a node is decided for that pod. Like a node is chosen for a pod by the scheduler. Then there is this cloud controller manager, which basically responsible for like communication between these cloud providers and the cluster. So cloud providers and the Kube API server. Then there is the controller manager. So controller manager would basically perform things like replacing the failed pods and scaling these resources, etc. So basically managing all the cluster lifecycle events. So this is it for the controller plane. Then in the nodes, you will see this kubelet. So kubelet is basically an agent which is performing this communication between the Kube API server and the container runtimes. So if the Kube API server wants to add a pod, then it will ask the kubelet, and then kubelet will tell the container runtime to pull all these container images and create a new container, etc. And then container runtime would do that thing. Also, Kubelet would be responsible for like checking the health of the pods, etc., by interacting with the container runtimes. Then there is this Kube-proxy, which is basically like it enables the communication between the services and the pods, and it ensures like node balancing, etc., inside this particular node. So then we have these pods. Pods are basically these abstraction over a container. So a pod would contain mostly a single container, and in some cases it will have like a container and one or more helper containers. And this is overall a node. So think of node as a basically it is like a virtual machine. So I think I have covered all the components now. So now let's see how these commands are executed, how the workflow is. Let me go to the terminal. So for example, whenever we add or whenever we create a pod, let me first delete pod if there is any, Nginx. So yes, we had this pod. It is deleted now. So now whenever we would say things like kubectl, like I have this configuration file, so it has created a particular pod. So what is basically happening under the hood, or what is basically happening in the cluster? So after we create, or we ask the kubectl to create a pod, it will send a request to this Kube API server. And firstly, the Kube API server will authenticate it. So this has admission controllers. So admission controllers are like, you can think of them as they decide whether the request should be allowed, should be entertained or not. So they can either mutate a request or they can validate a request. And then there are like two types of admission controllers: built-in admission controller, dynamic admission controllers. So what basically happens is the command from kubectl is given to the Kube API server, and then this Kube API server will communicate to the HCD, and it will tell that, okay, this is the pod we are, or this is the resource that we are trying to create, and these are all the specification of that particular resource basically. So all the specification of the pod, for example, we are creating a pod, so all its specification will be added to this HCD in form of key values. And then what happens is the scheduler will monitor this HCD. So what happens is it will find out that HCD has a pod which is not scheduled as of now. So the scheduler will look all the nodes, all the worker nodes, and it will decide, okay, this pod should be added to, for example, node 1. So the Kube API server will ask the HCD to update the pod spec and say that, okay, the pod is to be added to the node 1. Then in the node 1, we have this kubelet. Every node has a kubelet. So this kubelet basically notices that, okay, in this node, we have a new pod assigned. So now what we do is kubelet would ask this container runtime to pull all these container images, or take the container images if they are cached locally, and then create these containers. And then once the container is running, the kubelet will go back to will communicate back to the Kube API server and say that, okay, now the pod is running. So the Kube API server will ask the HCD to update its state that, okay, now the pod is running. And then, and that is it basically. Then if we say kubectl get command, get pods, then we can basically send the details through HCD. Through, like, the HCD will give it to the Kube API server, and it will give it to the kubectl. Kubectl basically displays the data to the user. So for example, now the pod is created. So now the user says kubectl get pods. It will go to the Kube API server, like I said earlier. It will do the validation and all. And then the Kube API server will ask this HCD for the configuration, like for the specifications of this particular pod. Not pod, we are saying get pods. So of all these pods, and then it will give all the data to the Kube API server, which will be sent back to the kubectl, and then the kubectl will display the data of all the pods, or will display the list of all the pods to the user.